Hello, and welcome on the tutorial on how to use the L-BeamO beam analysis graphical user interface, or GUI. As you can see right here, this is the actual MATLAB code that was developed in order for this GUI to function. If we play run, the GUI will appear. Right here we have a variety of options. First of all, you have to input the amount of point loads or distributed loads that you would like to enter. We have the default value at 1, so we'll just go ahead and add one load for each. So we'll click Add Loads, and now the Analyze button is enabled. Now we can actually play around and change the values of these loads. How about we change this to 0, and we'll leave this the same. We also have to enter parameters for the beam, such as the modulus of elasticity, the length of the beam, its inertia, the tension, and the number of sections. These are basic default values that we will use for the actual analysis. Okay, now let's try to analyze the beam. Well, first we actually have to select the beam type, or else we'll be prompted to do so. So we'll just click OK. Now let's try a simply supported beam, one of our two options. Now when we press Analyze, as you can see, there you go. Right here we have a drawing of the beam loading, with the blue line being the actual beam. As you can see, the supports right there, and the red line is the distributed load, as we have one of 10 pounds per foot, starting at 0 and going to the full extent of the beam. We have the deflection being displayed right here in an exaggerated mode. We have the shear diagram and the moment diagram. Now we can actually run this process for a cantilever beam. For this beam, we'll keep the same loadings, and we'll go back to Analyze. And there you go. Here's a typical deflection for a cantilever beam, its shear diagram, and its moment diagram. And as you can see, since the loading stayed the same, the beam diagram stayed the same as well. And there you go. That is how to use the L-BeamO beam analysis graphical user interface. Thank you.